Hello and welcome to Algebra 2 tutorial. In this video, we're going to take a look at what it takes to extend our trig functions beyond 90 degrees. Usually those only work up to 90 degrees because if you go past 90 degrees, you won't have a triangle anymore. So to figure this out, we first have to put our triangle inside a circle. So first let's take a look at what that is, and then we'll be able to go beyond 90 by extending our triangle inside of the circle. So here our triangle, we have our right triangle again. Let me mark that as a right triangle. And all we did is we put it inside a circle, and our angle theta is right here at the bottom left. I've got it in radians, it's 1.05 radians. First thing I want to make sure we can do is label the different sides of the triangle. So if this is the angle right here, theta, then our opposite side is over here, the vertical edge. And our adjacent side is the horizontal edge, adjacent. And so if we want to take a look at what all our trig function ratios are, we'll use the vertical value and we'll use the horizontal value. So let's start off with the original three, sine, cosine, and tangent. So sine of theta, so my theta in this case is 1.05, is equal to, so it's going to be the opposite, this one right here, over the hypotenuse, which is right here. So the opposite is our vertical, which is how long is this side? Well, that is the same as our y value. So it's 6.93 divided by the hypotenuse. Well, that's this edge right here. And that happens to be the radius of our circle. It is labeled here as 8, but you can also see that our radius goes from the middle out to the edge, which is 8. So our radius there is 8. All right, let's do cosine now. Again, our angle is the same, so it's still 1.05 radians. Is equal to the adjacent. Well, the adjacent is now this horizontal side, which that is our x value, which is 4. Over, again, the hypotenuse is the same as the radius, so that is 8. And our last one, tangent of 1.05 is going to be our opposite, which was our y value, 6.93. divided by the adjacent, which is the x value, which was 4. Now that we have those, the other three trig ratios are really easy. They're just the reciprocals. So the reciprocal of sine is you cannot see that. Cosecant of 1.05. And we just take the reciprocal, so that's 8 over 6.93. And then the reciprocal of cosine is secant. Flip that one, 8 over 4. And the reciprocal of tangent is cotangent. And we'll flip that one, so it is 4 over 6.93. So one important concept to get from this exercise, if you caught it, is the fact that our opposite side is our y value, and our adjacent side is our x value. That's worth writing down. So the opposite side is the same as the x. The adjacent side, I said that wrong. The opposite side is the same as the y. The adjacent is the same as the x. And the hypotenuse is the same as the radius. So as we move to try and extend our trig functions beyond 90 degrees, those three concepts are going to be very important. There's what's going to allow us to do this. All right, now that makes sense as long as our triangle is in the first quadrant. That is when our angle is less than 90 degrees. We want to now extend that to go beyond 90 degrees. It makes sense inside the triangle. We can find our opposite. We can find our adjacent. But if we want to go beyond 90, let's take a look at that. So first, I want you to take a look and see what happens if we go beyond 90 degrees. So here I have the same diagram, but I can move the triangle. So everything hopefully makes sense. In the top right, we have our adjacent is our x and our opposite is our y. But take a look at what happens when we go past 90 degrees. Straight up, and our triangle flips over to the other side. Our angle is no longer inside the triangle. The angle is on the outside. But if we use our understandings from the previous problem, our opposite side is still going to be the y value, and our adjacent value is still going to be the x value. And so we can still do our ratios using y and x, but it will be for an angle outside the triangle this time. So let me do one example that looks like that. So here we have our triangle on the bottom left side. Our angle goes all the way around to the third quadrant. It's on the outside of the triangle this time. But we can now still define sine, cosine, and tangent. So now I'm going to do sine. Now my angle is much bigger. The angle is 3.5. Now to find the opposite over the hypotenuse, the opposite is the y value. So I come to either, this is my y value here, but I'm going to get that from the point. So there is the y value, negative 1.42. Divided by the hypotenuse, but another word for hypotenuse is the radius. I do have it labeled here, but you can also see the radius right here is 4. All right, then cosine, just so we can practice all the ratios of 3.5. So our adjacent is our x value, so negative 3.74, divided by our hypotenuse, which is again 4, and then tangent of 3.5 is equal to the opposite, which is our x value, negative 1.42, divided by our adjacent, which is our x value, negative 3.74. So again, we're able to do this sine, cosine, and tangent ratio beyond 90 degrees, beyond our right angle, because we're using the basic information that the opposite side is the same as the y, the adjacent is the same as the x, and the hypotenuse is the radius of the circle. All right. Hopefully that makes some sense for you. I'd like to give you a practice problem here to try that out. For both of these, identify all 6 trig ratios for the angle that's given, using the fact that the y value is your opposite, the x value is your adjacent, and the radius of the circle is your hypotenuse. Good luck.